Position is the point or location of an object in space. So if we have a point here, this is a position of an object. But how can we actually decipher where exactly this object is? We can do this from a two-dimensional perspective or a three-dimensional perspective. Now, the one that's more common is the two-dimensional perspective for O-level physics, where you have the y-axis and you have x-axis. So the coordinates for this position will be given in terms of the y and x-axis as follows. So let's say this is point A. The coordinates might be, for example, 3, 5, or let's put it 5, 3, since we're more distant on the x-axis. So this corresponds to 5 and this corresponds to 3. Now the convention which write it, you start with the x-axis and then the y-axis. So we always start with the x-axis. This is what we call coordinates or position. So we can tell the position of an object from a two-dimensional perspective by getting its corresponding reading from the x and y axis respectively. But from a 3D perspective, we make use of a third axis called the z-axis. So we don't just have the y-axis and the x-axis, we also have z-axis. So this is normally used to represent three-dimensional objects. So right here I can even sketch a box and you can tell the position of the box 3D in space. So what's really relevant to us is two-dimensional. So let's get into it. Now distance is the interval between any two points, any two positions. So let's say we have point A and then we have point B. The interval between these 2 points is called the distance from point A to B. That's how much ground covered from point A to B. Now it's not always in a straight line. We could have a path from point A to B as, let's say, start here, come here, move up, and then before we finally get to B. This is also distance. How much ground covered before getting to our final destination is also called distance. Displacement, on the other hand, can be referred to as the shortest path taken in a straight line to reach our destination. So although this might be the distance from point A to B, that's the path followed, but the displacement is always going to be a straight line. Please remember that the displacement is always going to be a straight line from one point to another. We'll take questions on this later. So I just showed you what the difference between distance and displacement is already. Okay, so let's take this diagram here. For example, we have points P, Q, R, S, T represented on x and y coordinates. These are all positions, right? And if you are asked to label the coordinates, how are we going to go about it? So I'm going to do that for P and for Q, then you can do the rest yourself. So for P, the coordinates, we always start from X. So we trace down from P to X axis and we see that it corresponds to 2. So we say 2 comma, and then we trace that point to the Y axis and we see it corresponds to 3. So this is the coordinates for the position or the point P. Now let me do that for Q. So we have point Q. So point Q, the coordinates are as follows. First start with the x-axis. Tracing down to the x-axis, we have -1, and then comma. On the y-axis, we have 2. So these are the coordinates of point P and point Q. Now you can also use the same method for the rest. For S, 4 on the x-axis, 2 on the y-axis. Now if you notice something on the x and y-axis, this part of the x-axis only consists of negative values, while this part consists of positive values only. Then for the y-axis, down below only consists of negative values, while the top consists of positive values. So let's take note of that as well. Alright, now we may be required to find the distance between any two given points. So for example, we may be asked to find what's the distance between point P and Q, or more accurately, what is the displacement between point P and Q. Now there is a simple formula we can just use. We can just use d squared, or you know what, let's just use square root over. So the distance between point P and point Q is given by x2 minus x1 in brackets squared plus bracket y2 minus y1 squared. So the first thing we do is identify what our x2 and our x1 is. Now remember the format. We always start with an x coordinate and then on the y-axis, right? That means it's safe to say that this first value here is an x value, right? And this first value here is an x value. So we can decide to take any one of these as our 1 or 2. What I mean specifically is, so let's say for example, let's take this as our position 1 and then this as our position 2. So here we clearly have x1 and here we clearly have x2 because this is our position 2. Then here we have y1 because this is our position 1, and then here we have y2 because this is our position 2. All we have to do is substitute into the formula and we're going to have something like this. Okay, so distance is equals to square root of x2. What is x2? This is x2 for position 2, right? In brackets -1 minus x1. What is x1? x1 is in position 1, so -2 squared plus y2. y2 is in position 2, so remember the second one just from this format. So the second one is y2, right? So we have 2 minus y1, so this is y1 minus 3 squared. So don't worry about negative sign because once you square it, it's going to become positive. Okay, so -1 minus 2 is what? Minus 1 minus 2 is minus 3. Minus 3, how do I know this? Simple number line. Look at this graph. Look at this graph here. So when we say minus 1 minus 2, minus 1, we go towards the left, right? Then minus 2, we go twice towards that same direction. So 1, 2. You can see we ended at minus 3. So that's why minus 1 minus 2 is minus 3. So we have minus 3 bracket squared plus 2 minus 3 is what? And whenever you subtract a small number from a large number, you're going to have a negative value. So we're going to have minus 1. Please, it's not 1, but it does not really matter because we're still going to square it at the end. So how did we even come out about this minus 1? If we can we use the number line? Can we use the graph to figure that out? Okay, let's go for it. So first number there is 2. This is not just 2, this is plus 2. It's a positive number. So plus 2, right? That means we're going to have to go positive towards the positive side twice. So plus 2, 1, 2. Plus 2 minus 3. So now after going plus 2, we have to go minus 3. Let me use a different color so you see it clearly. So minus 1 minus 2 minus 3. I hope you can see that we ended in minus 1 as we have written here. So that's how we go about it. Okay, so minus 3 squared is 9. Just empty out 3 squared. So 9 plus minus 1 squared is 1. So we have 10. Therefore our distance is equals to, remember these square roots. So square root of 10, and this is our answer for the distance between points P and Q. Alright, so whenever you're asked to find the distance between 2 points, you just apply this formula and you are good to go. Alright, so let's talk about bearing. To understand bearing, you need to know the 4 cardinal points. I don't know if that's what's called, but you need to know your north, your east, your west, your south. So it's very simple. North always points upwards. Once you know the direction of your north, you know the direction of every other side. So north, from the north you have to move in a clockwise direction and just spell out the word NES W. That's if you are very forgetful of which side is east, which side is west. Just spell out the word NES W. So let's do that now. So we have north, followed by east, followed by south, and finally west. So NES W. Always remember that so you get direction right every single time. So east is towards the right, and then west is towards the left. Okay, so now that we understand these 4 main directions, you need to note that anything in between, any direction in between, is given as a hybrid of both directions, because on both directions at the same time. So it's both north and east here, and any direction between south and west, we call it southwest. Any direction between north and west is going to be northwest, so on and so forth. Okay, so now let's take a more practical example. Suppose we say north 60 degrees east. What does it mean? So when we say north 60-degree east, it just means north 60 degrees towards the east, and then we draw our direction. That's what north 60 degrees east mean. Also, we can see something like 60 degrees east of north. It means the same thing. These two mean exactly the same thing. To interpret this, 60 degrees east of north, it means 60 degrees coming from the north. So 60 degrees coming from the north is 60 degrees east of north, which is the same thing as north 60 degrees east. So knowing this alone will help you understand this topic better when we start treating complex cases. Okay, we can also have, let's say for example, 30 degrees north of east. What does this mean? 30 degrees north of east means 30 degrees north from the east, coming from the east. So how are we going to represent 30 degrees north of east on this diagram? So 30 degrees north of east, 30 degrees coming from the east. Now I can also use the same line as our direction, because definitely each of these 4 quadrants are 90 degrees. So 60 plus 30 degrees is 90 degrees. So this is our direction as well for 30 degrees north of east. Now I hope you understand. Alright, so let's do a case where we have more than one point to deal with. For example, they say the bearing of a point A from point B is 60 degrees. 60 degrees. Whenever you are given just the angle, just an angle, you know it's going to be coming from the north. It always starts from the north. So you just draw your 4 quadrants, right? And then you start from the north 60 degrees. And then you draw another 4 quadrants where it meets at point. So this is point A. Sorry, this is point B, and this is point A. Remember I said the bearing of point A from point B. So point B is 60 degrees. That's why we drew point B first and got 60 degrees. And then we connect it to another quadrant. That's point A. So now we can read the bearing of point A. So doing this, what is the bearing of point A? Now, remember we always read from the north. So I'm going to start from the north and read up to that point. So this, we have 90 degrees, 90 plus 90, 180 degrees, 180 plus this angle here, we have 180 degrees plus 60 degrees. Why 60 degrees? These are opposite angles, so they're going to be the same. 60 degrees here, 60 degrees also means 60 degrees will be here. So the total angle is equals to 240 degrees. So the whole angle from the north down to this point is 240 degrees. That means the bearing of point A is 240 degrees, and that's our answer. Okay, so let's say we have another question. The bearing of P from Q is 210 degrees. What is the bearing of P? So we need to find out what the bearing of P is from Q, which is 210 degrees. So how do we represent it? First, we draw our point Q, four quadrants or two axes, x and y axis. So this is our north, right? And we always start our reading from the north. Remember that. So this is true bearing. It's called true bearing from the north. So this is 90 degrees, 180 degrees. So we have 180 already. It means we're close to 210. So what are we going to add to 180 to get 210 degrees? I'm going to have to add 30 degrees. So it means we can put our line somewhere here. That's a very horrible looking line. So we can put our line somewhere here and just call here 30 degrees, right? But this entire angle is 210 degrees. Down to this point. Okay, so what is the bearing of P? To get the bearing of P, we just need to draw our X and okay, I didn't draw that very well. Okay, now remember opposite angles. If here is 30 degrees, it means here will also be 30 degrees. And remember, this is north and this is your east. Therefore, the bearing of P is what? North, 30 degrees, 30 degrees east. And that's our answer. So let's take one more problem. So something I forgot to mention along the way is whenever you hear anything like due east or west or due north, it means directly towards the east or directly towards the north. So let's take a problem on distance and displacement. All right, so let's take a look at this question. A man wishes to walk to his house. He first walks 4 kilometers due east, then 6 kilometers north, 3 kilometers east, and then finally 5 kilometers south to get to his house. Calculate the distance covered and his displacement. So these are two different things, distance and displacement. Remember, distance is a scalar quantity, no particular direction, just how much ground covered. And then displacement is a vector quantity, has both magnitude and direction. To get the distance covered, all we have to do is just add up the total ground covered. So we can just add up 4 kilometers, 6 kilometers, 3 kilometers, and 5 kilometers together. That's going to give us 4 plus 6, 10, 10 plus 3, 13, and then we have 18 kilometers total. So total distance is equals to 18 kilometers. But where it really gets tricky is when it comes to displacement. So we have to actually sketch a diagram for this question so we know exactly what we're doing. Now, he first walks 4 kilometers due east, right? So where is our eastern direction? This way, right? So 4 kilometers due east. Let me just label this 4 kilometer. And then 6 kilometers to the north. Okay, so he walks 6 kilometers to the north. And then 3 kilometers to the east. Okay, that's too long for 3 kilometers. 3 kilometers to the east, and then 5 kilometers south. So we have to come down 5 kilometers south. So the question is asking, what is this displacement? So this was the start position, and then this was where he ended. Already calculated the distance, that is how much ground covered: 4 kilometers plus 6 kilometers plus 3 kilometers plus 5 kilometers, and we ended up at 18 kilometers total for distance. But the displacement, however, is going to be in a particular direction, a straight line drawn from the starting point to the end position. So I'm going to draw kind of a line, sort of a broken line, to show that straight line. So instead of walking this long journey, this man could have easily just walked straight ahead and gotten to his house, and that's exactly what we have to calculate for displacement. The distance covered in a straight line, shortest distance, is what we know as, or what we refer to as, displacement. So looking at this right now, we just have to form a right angle triangle. So I'm going to use another broken line here, and we can see that the distance, let me use a red marker so you can clearly see that the distance here is 1 kilometers. Why is it 1 kilometer? If from here to here is 6 kilometers and from here to here is 5 kilometers, it means this distance here is 1 kilometers. So I can already sketch out my right angle triangle, and I know it's something like this, where the bottom is 1 kilometers, and then we're looking for the displacement, and then we have 4 kilometers here, and then this bottom, it corresponds to this 3 kilometers. So here's also 3 kilometers. 4 kilometers plus 3 kilometers is what? 7 kilometers. So we have 7 kilometers total. So to get to the displacement, we have to use Pythagoras theorem. Pythagoras theorem says that hypotenuse square is equal to the sum of the square of the other two sides. So 7 squared plus 1 squared. So this square is equal to 49 plus 1. So this is equal to square root of 48. Whatever answer we get here is going to be the displacement. So we're going to have something like 7 point something. So you can see clearly that the displacement is way shorter, is a way shorter route than the distance covered. Okay, so before we treat this question, let's take one more example on distance and displacement. So you may be given a circle, or rather a semicircle, I don't know what kind of circle this is. Okay, just manage my diagram. All right, so the radius of the circle can be given as let's say they give you the radius as 10 cm. Calculate the distance between point A and B, the distance and the displacement. So from our knowledge of distance and displacement, the distance is going to be along the circumference from point A to B. That's going to be the distance, while the displacement is going to be in a straight line from A to B. So if they ask you what the displacement is, you already know the answer. Since the radius is 10 cm, we have another radius here, 10 cm, to form the diameter. Therefore, the displacement is equals to 20 cm, while the distance along the curved path, you have to use the formula for circumference, but I'm just trying to drive home a point. So that's basically it. Let's take this question. An aircraft traveled from Calabar to Kano as follows. It first flew to Ilorin, covering a distance of 300 kilometers, 30 degrees west of north. Okay, so let's just try sketching something. We know I have to draw our x and y axis or our 4 quadrants, right? So let's just call this Calabar. From Calabar to Kano, we want to get to Kano, but first we flew to Ilorin. So to Ilorin, covering a distance of 300 kilometers, 30 degrees west of north. Where's our western direction? So this is west, this is north. So we are going 30 degrees west of north. That means coming from the north, 30 degrees. That means our diagram is going to go this way. So I have to adjust it and draw my diagram there. Okay, so 30 degrees west of north. Okay, so let's go. So from Ilorin, what do we have next? So this is Calabar and this is Ilorin. The distance is 300 kilometers. So from Ilorin, we flew 400 kilometers, 60 degrees east of north to Kano. So where's our east? This is our eastern direction, this is our northern direction. So 60 degrees east of north, we are going to draw it like this. So 60 degrees east of north to Kano. So I'm going to label this as Kano. Okay, let's get on to it. So the question says we should find the resultant distance. So this is 400 kilometers. This is 300 kilometers. The first step to finding the resultant of two vectors acting at a point is to find the angle that is situated between them, the angle to which they are inclined to one another. So how do we do that from this bearing? from our knowledge of bearing. If this is 30 degrees, then this part also is going to be 30 degrees because of opposite angles, right? And then since this part is 30 degrees, because this entire angle is 90 degrees, 90 minus 30 is going to give us 60 degrees here. And then for this part, because this is 60 degrees, 60 minus 90 will give us this remaining part here. 60 minus 90 is going to give us the remaining 30 degrees. So the total angle in between the two vectors, 400 kilometer and 300 kilometer, is 90 degrees. So to find the resultant, we can either apply Pythagoras using a right angle triangle, because this is 90 degree obviously. We can use an easy method and just say, okay, fine, because that's 90 degrees, we can just put 400 kilometers here and then 300 kilometers here, and then find the resultant. So the resultant is going to be the hypotenuse. R squared is equals to 400 squared plus 300 squared. So R squared is equals to 400 squared is 160,000. Okay, 160,000 plus 300 squared is what? 3 times 3 is 9, so we have 9. Then 0 into 2 places, we're going to have 90,000. Adding them both, we're going to end up with square root of 250,000. Square root of 250,000 is 500 kilometers. $250,000. Yeah, okay. So that's 500 kilometers, and as you can see, that's our answer, option D. Now you may have a question. So what if the angle between them was not 90 degrees? Let's say the angle between them was, for example, let's say the angle between them was 120 degrees. How do we go about it? We can just use cosine rule. That is parallelogram law of vectors. The formula is similar to Pythagoras, but it goes like this. Because r squared is equals to, so a squared plus b squared, then plus 2ab cos theta. Theta is the angle between the two forces. So let's go. We have r squared is equals to, a squared is our 400 kilometers squared plus 300 kilometers squared plus 2 times 400 times 300 cos. Okay, so instead of using the new angle which we put there, 120 degrees, let's even use the 90 instead to see if we are going to get the same answer. So I'm going to use the 90 there, and you can see clearly that cos 90 is 0. Cos 90 is 0, so 0 multiplied through all this, that means everything here is 0. So we're even back to just Pythagoras theorem.